So, welcome back to Top 10 Worldwide. Today we're diving into artificial intelligence, a topic that's everywhere but with roots deeper than you might think. AI isn't just about chatbots or image generators, its story stretches from ancient myths to the technology reshaping our world right now. We'll trace the journey from early dreams of mechanical minds to the breakthroughs and setbacks that led to today's generative AI. Get ready for the 10 pivotal moments that transformed AI from fantasy to reality. This is the history of AI, from myths to modern marvels. To understand AI, we have to go way back. Before computers, before electricity. The idea of artificial beings is ancient, woven into myths like the Greek god Hephaestus's mechanical servants and the bronze giant Talos. These stories show humanity's early fascination with creating lifelike intelligence. Medieval legends like the Golem and inventions like Hero of Alexandria's automata kept the dream alive. Philosophers like Ramon Lull even tried to mechanize reasoning with devices like the Ars Magna, an early attempt to formalize thought. These myths and inventions weren't just fantasy, they planted the seeds for robotics and AI. The core questions, can we create an artificial mind, and what are the risks, are still with us today. This era set the ambition for everything that followed. Before we could build AI, we had to imagine it. The dream began long before the first computer. Fast forward to the 20th century and meet Alan Turing, the mathematician who turned AI from dream to possibility. Turing's concept of the Turing machine laid the foundation for modern computers, a universal device that could, in theory, perform any computation. But how would we know if a machine was truly intelligent? Turing's answer? The Turing Test. If a human judge can't tell the difference between a machine and a person in conversation, the machine passes. This shifted AI from philosophy to engineering, giving researchers a concrete goal. Turing's work, alongside pioneers like Church and Gödel, moved AI into the realm of logic and mathematics. The first electronic computers like Colossus made these ideas real. Turing didn't build AI, but he gave us the blueprint and the test. The race to create thinking machines had officially begun. The age of computing was here. The field of AI needed a name and a community, and it got both in 1956 at the Dartmouth Conference. Organized by John McCarthy, Marvin Minsky, and others, this workshop was the birthplace of artificial intelligence as a discipline. Their bold proposal: every aspect of intelligence could, in principle, be simulated by a machine. McCarthy coined the term artificial intelligence, uniting researchers with a common goal. Attendees included pioneers like Newell, Simon, and Samuel, who were already building early AI programs. The conference didn't solve AI, but it set the agenda for decades, defining the field's core questions. It legitimized AI, attracted funding, and launched the first wave of research. The optimism was infectious, and the modern era of AI began. The starting gun had fired. With the Dartmouth spark, it was time to build real AI. The logic theorist created by Newell and Simon was the first AI program, proving mathematical theorems and showing computers could reason with symbols. This was symbolic AI, representing thought as symbols and manipulating them with logic. But AI needed to act, not just think. Enter Shaky the robot, built at Stanford in the late 1960s. Shaky was the first robot to perceive its environment, build a map, and plan actions to achieve goals. Its software, Strips, broke down complex tasks into manageable steps, a breakthrough in AI planning. Shaky could navigate, avoid obstacles, and execute commands in a real-world setting. These projects proved AI could solve abstract problems and interact with the physical world. They were limited, but they showed the principles worked. The first steps were small, but they changed everything. AI was no longer just theory. The journey from thought to action had begun. Early AI progress sparked bold predictions and big funding, but reality hit hard. Programs like Shaky worked only in controlled environments. Real-world complexity was overwhelming. Language programs failed outside simple scenarios, and computers weren't powerful enough to scale up. Disillusionment set in. The 1973 Lighthill report criticized AI's lack of progress, leading to funding cuts. DARPA shifted focus, and the term AI became toxic. The field entered the first AI winter, funding dried up, optimism faded, and researchers rebranded their work. Theoretical challenges like combinatorial explosion and the limits of early neural networks stalled progress. But the winter wasn't wasted. It forced AI to mature, focus on practical problems, and recognize its limits. The hype was gone, but the lessons were crucial. AI had to regroup and rethink. The cold season set the stage for the next breakthrough. Sometimes progress needs a pause. AI's comeback came in the 1980s with expert systems, programs that captured human expertise in narrow domains. Instead of general intelligence, these systems focused on specific tasks, like diagnosing diseases or configuring computers. Mycin, for example, diagnosed blood infections as well as top doctors using a knowledge base of rules. XCon automated computer system orders, saving millions for Digital Equipment Corporation. Expert systems proved AI's real-world value, sparking a commercial boom and a billion-dollar industry. But they were expensive, brittle, and struggled outside their narrow focus. Still, this era rebuilt confidence in AI and showed it could solve complex practical problems. The AI spring had arrived, the field was back in business. Expert systems weren't perfect, but they were proof AI could deliver. The foundation for future growth was set. AI hit the global stage in 1997 when IBM's Deep Blue defeated world chess champion Garry Kasparov. This wasn't just a technical feat, it was a cultural moment. Deep Blue, a specialized supercomputer, could evaluate 200 million chess positions per second. The match was tense, dramatic, and watched worldwide. Kasparov's defeat symbolized AI's arrival as a real force. Deep Blue wasn't general intelligence, it couldn't play checkers or hold a conversation. But its victory showed the power of computation and sparked new interest in AI. The public saw AI as more than theory, it was a competitor. The symbolism mattered more than the technology. AI had proven it could surpass human genius in a complex domain. The world took notice. The game had changed. The age of man versus machine had begun. While symbolic AI and expert systems dominated, neural networks, AI inspired by the brain, were quietly making a comeback. The breakthrough was backpropagation, an algorithm that let networks learn from mistakes by adjusting connections based on errors. Instead of hand-coding rules, AI could now learn directly from data. The rise of computing power and the internet provided the data and hardware needed to train these networks. Yann LeCun's convolutional neural networks could read handwritten digits, proving neural networks' power for real-world tasks. This era marked the shift from programming intelligence to training it. The seeds of modern machine learning were planted. The quiet revolution was underway. Data-driven AI was on the rise. The stage was set for explosive growth. The 2010 saw deep learning explode, taking AI from lab demos to superhuman feats. In 2012, AlexNet, a deep neural network, crushed the ImageNet competition, thanks to GPUs and massive data. This kicked off an arms race to build deeper, more powerful models. In 2016, AlphaGo defeated Go champion Lee Sedol, using deep learning and reinforcement learning to develop creative strategies. AlphaGo's unexpected moves stunned experts, showing AI could innovate, not just calculate. These breakthroughs proved AI could surpass humans in perception and strategy. Deep learning became the engine behind advances in vision, language, and more. The revolution was real, and it was deep. AI was now everywhere, from photo apps to medical imaging. The possibilities seemed limitless. The deep learning era had arrived. The world was watching. The future was unfolding fast. Now, we're in the age of generative AI, where machines don't just analyze, they create. The breakthrough was the transformer architecture, introduced in 2017, enabling models to understand context and scale up. This led to large language models like GPT, trained on vast internet data to generate text, code, and more. The release of ChatGPT in 2022 brought AI to millions, making it accessible and interactive for everyone. Generative models like DALL-E and Midjourney can create images, music, and even video from simple prompts. AI is now a tool for creativity, not just analysis. The technology is transforming industries and raising new questions about creativity, work, and humanity. Progress is faster and more widespread than ever. We're at the start of a new chapter. The journey from myth to machine has led us here. AI can now talk, write, and create alongside us. The impact is everywhere. The future is being written in real time. That's the story of AI, 10 moments from ancient dreams to today's generative marvels. Each step built on the last, bringing us to this pivotal point in history. The story isn't over, in fact it's just getting started. AI is evolving at breakneck speed, shaping our world in ways we're only beginning to understand. The future promises both incredible opportunities and complex challenges. Stay curious, stay informed, and join us as we explore what's next. If you enjoyed this, like, share, and subscribe to Top 10 Worldwide for more insights. Thanks for watching. We'll see you in the next one.